Hi class, we continue our study in chapter 7 talking about similarity by moving into section 7.3. 7.3 is talking about similar polygons. So we have two objectives in this section. First is we want to identify what exactly is a similar polygon. And then the second thing we want to do is we want to use similar polygons to solve applications. And I have an application problem picked out at the end of this lecture. Okay, so first off, similar polygons, similar figures, we'll talk about that first, have the same shape, but not necessarily the same side. So we abbreviate it with the notation is similar to with this symbol, this squiggly line. So what the squiggly line means is similar to. So two polygons are similar polygons if corresponding angles are congruent, so all the angles are the same, and if the lengths of corresponding sides are proportional. So if we were to say polygon ABCD is similar to polygon GHIJ, what you would notice here is that the angles would be congruent, right? So A would be the same congruent to G, B would be congruent to H, C would be congruent to I, and D would be congruent to J. And then what would have to happen is the ratio of the corresponding sides. So A to B would be is congruent, or not congruent, excuse me. The ratio of side AB to GH is equal to the ratio of side BC to HI is equal to the ratio of side CD to IJ is equal to the ratio of AD to GJ. If all those are the same, then the ratios are equivalent, then these polygons are similar. All right, similarly, we write a similarity statement with corresponding vertices in order. So the same way we write a congruence statement. So when there are three or more ratios are equal, we can write an extended proportion. So the proportion A to B, side AB to GH, so on, is what we call an extended proportion. Right? Kind of just like the same way we were doing with the extended ratios. All right, so let's talk about understanding similarity and using extended proportions. So first off, forgive the typo here, just didn't come over. Triangle MNP is similar to, that's what that's supposed to be there, but it's not showing up, is similar to triangle SRT. So since they're similar, what are the pairs of congruent angles? Well, this looks like the flip of this. So use the order of the vertices in the similar statement. Triangle MNP is similar to triangle SRT to write pairs of congruent angles. So it has to be that angle M is congruent to angle S, angle N is congruent to angle R, and angle P is congruent to angle T. So notice how M and S angles are congruent, N and R is congruent, and P and T are congruent. Basically the angles with the same way you wrote the triangle out. All right, what is the extended proportion for the ratios of the corresponding sides? Well, again, follow that same method. Since triangle MNP is congruent to triangle SRT, we know that MN corresponds to SR. So MN, SR is a ratio of corresponding sides. The same is true for the following. MN to SR, right, is congruent or equal to NP to RT, okay, in order, and then MP, the ratio of MP to ST, all these ratios are the same or equal to each other. All right, talk about now a scale factor. So scale factor is the ratio of corresponding linear measurements of two similar figures. The ratio of the lengths of corresponding sides, side BC and YZ, or more simply stated, the ratio of corresponding sides is, so if we have this side BC, which is of 20, another side YZ is 8, 20 to 8 simplifies to 5 to 2, so all we're saying is the scale factor is 5 to 2, right? All right, so let's move on. So let's determining similarity using this scale factor, what I talked about. So for the figures in A and B, right, answer part 1 and part 2. So the first one is we take these two shapes here and we ask, are these polygons similar? If they are, write a similarity statement and give the scale factor. All right. So first off, you have to talk about identifying pairs of congruent angles and make sure they all match up. So we see that J is congruent to T, which is great, K to U, L to V, and M to W. So they're all congruent there. So that's the angles are congruent. That's perfect. Now what has to happen, the harder part, is you have to find the ratios of the corresponding sides. So we'll start this way. JK to TU is 12 to 6, which is 2 to 1. KL to UV, 24 to 16. Right? Well, that has a ratio of 3 to 2. LM to VW, 24 to 14. That has a ratio of 12 to 7. And then finally, JM to TW here has a ratio of 6 to 6 or 1 to 1. So corresponding sides are not proportional since the scale factors are not the same. So the polygons here are not similar. All these scale factors here would have had to have been exactly the same, right, for these polygons to be similar. All right, let's try a different one, okay? For the figures in A and B, so right here, A and B, answer the same things, parts 1 and 2. So are the polygons similar? And part 2, if they are, write a similarity statement and give the scale factor. All right, well, we see here that angle C is congruent to angle F. That's fine. B is congruent to E. That's fine too. And A is congruent to D. That's fine. All right, so the parts of the corresponding angles of the triangle here are congruent. So what we have to look at is the scale factor of the ratio of the sides and see that they're all the same. All right, so let's do that. So start with AB is congruent, or the ratio of AB to DE, which is right here, that's the congruent side, or the corresponding side, is 12 to 15, so that has a scale factor of 4 to 5. The ratio of BC to EF, well, BC is 16 to 20, that simplifies to 4/5, so the scale factor is 4/5. And finally, AC is 8, DF is 10, right? 8 to 10 simplifies to 4 to 5. So they have the same scale factor. So yes, we can say that triangle ABC is similar. This is what I mean by saying, right, the similarity statement. Triangle ABC is similar to triangle DEF. And the scale factor here, right, the ratio of the sides is 4 to 5. All right. Let's try another one, multiple choice. If I tell you that polygon ABCD, so this big polygon out here, ABCD, is similar to the smaller one, EFGD, what is the value of this x here? All right, well, how are we going to do this? I have all these options. So we're going to have to use the similarity statement to write a proportion. So let's start with FG right here is the ratio of FG to BC has to be the same as the ratio of ED here to AD. So when I put that here, the ratio of x to 7.5 is equal to the ratio of 6 to 9, right? Because they're similar. So solving this, cross multiply here. X times 9 gets me 9x. 6 times 7.5 gets me 45. And just dividing by 5 here, you get x is equal to 5. Right, so there it is. The value of x is 5, so the correct answer is B. All right, one last example. So your class is making a rectangular poster for a rally. The poster's design is 6 inches in width by 10 inches in length. The space allowed for the poster, however, is 4 feet in width by 8 feet in length. So what are the dimensions of the largest poster that will fit in this space? Now, it doesn't have to be a perfect fit, but just like what is the largest that'll fit in the space? All right, so the first thing you want to do is determine whether the width or the length will fill the space first. So we know that 4 feet is 48 inches. So how many times will 6 inches fit into 4 feet? Well, we divide, that'll be at max 8 times. If you do it with the length, 8 feet is equal to 96 inches. So how many times will that length of 10 inch fit into 8 feet? Well, divide 96 by 10 inches, you get 9.6. So what we see is that design that you can make can be enlarged at most 8 times, right? So the smaller of the two quotients here. All right, so the second thing, the greatest width is 48 inches. So find the length. So 6 inches to 48 inches, the ratio. So the length goes 10 inches to how many is the farthest we can make it. So cross multiply here. 6x is equal to 480. Divide by 6, you get x is equal to 80 inches. All right, so the largest poster that will fit is 48 inches by 80 inches, or 4 feet by 20 divided by 3 feet, or 4 feet by 6 2/3 feet.